For decades, seeing yellow paint under the hood meant you owned the road. The 3406, the C15, the 6NZ. These engines were so bulletproof that truckers would mortgage their homes just to spec one in a new rig. Then, in June 2008, Caterpillar simply walked away. There was no bankruptcy, no hostile takeover. It was just a press release and a spreadsheet. This is the story of boardroom gambles, toxic exhaust, a $60 million betrayal, and the accidental birth of a rival dynasty. It was the greatest strategic retreat in American industrial history. Caterpillar didn't fail, they quit. And the reason why will change how you think about every Mapleton casting and Mossville block you have ever run. To understand why they left, you have to understand what they built. And to understand what they built, you have to go back to the dirt. Caterpillar wasn't born on the highway. Benjamin Holt built the first track-type tractor in 1904 in the soft farmland of California because his steam machines kept sinking into the earth. The solution was brutal and simple. Spread the weight and keep moving. That blueprint, that instinct to overbuild rather than compromise, got poured into every engine Peoria ever stamped with a serial number. When they eventually turned that same engineering philosophy toward commercial trucking, they didn't build a highway engine. They built a tank that happened to fit between frame rails. The first serious highway Caterpillar engine was the 1693 in the late 1960s, a 14.6-liter inline-six with dual overhead cams and 4 valves per cylinder. Mechanics called it the Clatterpillar. The pre-combustion chambers made a noise like someone shaking a bucket of bolts, but that rattle meant fuel was igniting exactly where it was supposed to. You could hear one coming from 2 miles out. In the mountains, that sound meant the load was moving. Then came the 3408 V8 in 1975. 18 liters, built so massive that the mining and marine blocks pushed over 2,000 pound-feet of torque and 800 horsepower without flinching. On the highway, that displacement was absurd, and that was the point. They built those blocks with so much headroom that the worst-case load on the worst-case grade was still just a Tuesday. But the engine that built the legend was the 3406B. Produced from 1983 through 1993, it was the peak of what you could do when a company refused to compromise. Forged steel crankshaft, individual mechanical unit injectors, thermal margins so conservative you could bury the throttle on a loaded grade and the block would shrug it off. A mechanical with a flathead screwdriver, a 7/16 wrench, and 45 minutes could pull that pump cover, adjust the fuel and torque screws, and walk out with 50 more horsepower than he walked in with. No laptop, no calibration software, no software at all. Just iron, physics, and a guy who understood both. Fleets didn't spec a 3406B because it was cheap. Cat parts cost more than the competition and everybody knew it. They spec'd it because the 3406B rebuilt at 800,000 miles cost less than an old 2-stroke Detroit 8V92 that needed an in-frame at 400,000. Total cost of ownership. The manufacturer drilled that math into every fleet manager in North America, and the math held up every single time. When the Motor Carrier Act of 1980 deregulated trucking, everything changed. Route monopolies died overnight. Rates got cut in half. The only way to survive was to move more freight faster. That meant horsepower mattered more than it ever had, and the owner-operator, the independent guy running his own authority on his own truck, became the cultural center of the industry. For those guys, the engine under the hood wasn't just a tool, it was a statement. A Cat hood badge on a Peterbilt 379 meant you had made it. You ran the best iron on the road, and everyone at the fuel stop knew it. By the mid-1990s, Peoria responded to the digital age with the 3406E. They ditched the mechanical injection pump entirely and moved to mechanically actuated, electronically controlled unit injectors running off the ADEM engine management system. The transition wasn't smooth. The earlier peak system on the 3406C was a disaster, so finicky and unreliable that drivers paid mechanics to rip it out and retrofit the old mechanical pump. But ADEM worked. It gave them the precision to extract more power and better fuel economy from the same basic architecture. And suddenly, you had a 6,000 horsepower highway engine that could still be tuned with a laptop instead of a screwdriver. Then came the 6NZ. Produced from 1999 to 2002, the C15 with the 6NZ serial prefix is still, to this day, considered the finest on-highway diesel engine ever built in North America. Single turbo, pre-emissions architecture, 8M2 and 8M3 controls. It combined everything the engineering team had learned over 30 years of highway engineering into one package with zero compromises. Because in 1999, the EPA had not yet forced any. A 6NZ running 80,000 pounds across the Rockies didn't ask for anything, it just pulled. The 6NZ was the peak of what the engine builder could do when the rules were simple. But the rules weren't simple anymore. Behind the scenes, the EPA had been building a case that would turn the entire diesel industry upside down. The entire heavy-duty diesel industry had spent the 1990s running a quiet con. The ECMs in these engines were programmed to recognize the EPA's standardized lab test and retard injection timing just enough to pass. Then, the second the truck hit highway speeds, the software advanced the timing back for maximum fuel economy and power. The engines were pumping out up to 3 times the legal NOx limit every mile they turned on the open road. CAT wasn't alone. Cummins, Detroit Diesel, Mack, Navistar, Volvo, and Renault were all running the same play. On 22nd of October 1998, the Department of Justice and the EPA shut it down. 7 manufacturers. The largest Clean Air Act enforcement action in history. The total settlement exceeded $1 billion. Their piece was $25 million in civil penalties, plus $35 million in mandatory environmental projects. The industry had sold roughly 1.3 million engines with these defeat devices, and in 1998 alone, those engines were responsible for over 1.3 million tons of excess NOx. EPA Administrator Carol Browner called them deceit devices, and she wasn't wrong. The EPA said that settlement would prevent 75 million tons of NOx from hitting the atmosphere by 2025. The fine hurt, but the clause buried in the consent decree was what broke the dam. The EPA pulled the compliance deadline for new emission standards forward by 15 months. Standards originally due in January 2004 were now due by October 2002. 15 months stripped from a development cycle that normally took years. Their engineers had the 6NZ running beautifully, and now the government told them they had roughly 24 months to replace it with something fundamentally different. They panicked. They had the finest highway engine ever built and 2 years to kill it. What came next would cost them everything. By the time 2001 rolled around, Caterpillar knew exactly where the rest of the industry was headed. Every major competitor was betting on exhaust gas recirculation, or EGR, which works by taking a hit of exhaust and cooling it down before piping it back into the intake. This lowers the peak temperature during combustion, and since lower temps mean less NOx, the system actually does what it's supposed to do. Cummins was using it, Detroit was using it, and the Europeans had already been running it for years, so the entire industry viewed EGR as the only real path forward. The heavy equipment giant looked at that setup and decided to walk the other way. In March of 2001, they did the unthinkable. While every other manufacturer was falling in line with the EPA's preferred solution, Peoria decided to bet the entire company on a technology that technically shouldn't have worked. They weren't just fighting the government, they were fighting a fundamental law of physics. Their reasoning wasn't just corporate stubbornness, because hot, soot-heavy exhaust gas is incredibly abrasive when you cycle it back through an intake manifold. It carries acids that eat away at components, and over time that grit degrades an engine from the inside out. The engineering team had spent 3 decades perfecting iron that could hit 1 million miles on the original block, and they weren't about to let the EPA turn their engines into self-destructing chemistry experiments. In March 2001, the company officially killed its EGR research and went all in on a new system they called ACERT. The goal of advanced combustion emissions reduction technology was to control the burn so perfectly that the exhaust came out clean the moment it ignited. There would be no dirty gas piped back in and no DEF tanks bolted to the frame, just a cleaner explosion managed entirely inside the cylinder. On paper, the engineering was a massive achievement that relied on 4 different systems working in total lockstep. A compound twin-turbo setup forced huge volumes of dense air into the chamber to dilute the burn, while variable valve actuation used pressurized oil to hold intake valves open longer and keep temperatures from spiking. They used unit injectors capable of multiple microbursts to shape the explosion rather than letting it detonate all at once. And a new ADEM computer processed every variable in real time to keep the balance. Peoria called this a systems approach, and they backed it up with over 250 patents and a development budget that climbed past $500 million. Jim Parker, the VP of Engine Marketing, admitted this was the most expensive program in company history. costing even more than the development of their famous high-drive tractors. In the lab, the gamble seemed to pay off. On a test stand in Mossville with a steady fuel supply and perfect air, the ACERT engines hit every emissions target without needing EGR or DEF. By 2004, the C15 ACERT held nearly 30% of the Class 8 market, and the company even picked up a J.D. Power Award in 2006. The trade magazines were calling it a revolution, but the celebration didn't last long. The development team wasn't just fighting the EPA. They were up against the ideal gas law, and no patent portfolio was going to change that. In a standard single-turbo setup, the air gets warm during compression, passes through the intercooler to shed heat, and enters the engine. In a compound twin-turbo system, the low-pressure turbo heats the air, and then the high-pressure turbo compresses that already hot air again. This isn't a design quirk. That is thermal load stacking on itself with every revolution. By the time the charge air left that second turbo, it was hot enough to destroy a standard front-mounted intercooler. Their answer was the jacket water precooler, a heat exchanger bolted directly to the block that used engine coolant to knock the temperature down before the air went forward. It worked, but every BTU it pulled out of the charge air went straight into the primary cooling circuit. The thermal load was stacking with every revolution, combustion heat, bearing friction, and now 2 full stages of compression heat dumped into the same circuit simultaneously. 80,000 pounds on a July grade, and the cooling system ran out of capacity fast. The problem got even worse once the engine was dropped into a truck. CAT's heavy equipment has room for massive radiators and hydraulic fans that pull air across the cores without any trouble. But a Peterbilt 387 or a Kenworth T2000 has a sloped fiberglass hood designed by people trying to cut wind resistance. The radiator opening was only about 34 inches tall, shaped to push air over the cab instead of through the engine bay. That ACERT needed a cooling package the size of a barn, but it was jammed inside what was basically a very expensive fiberglass oven, and the heat had nowhere to go. Under that hood, the heat climbed way past what the electrical parts were built to handle. Pull a valve cover on one of these engines after 60,000 miles, and you'd find wiring harnesses that looked like they'd been left on a griddle. Insulation cracked, copper exposed, engine oil wicked up through the degraded sheathing until it shorted the injector connectors dead. The plastic connectors on the VVA solenoids shattered from the heat cycling. The heavy studs holding the injector units snapped. When a VVA unit failed, the engine dropped into a rough idle and lit the dash up like a Christmas tree. The metal bellows connecting the turbos cracked from thermal fatigue, which killed the boost and made every other failure accelerate faster. Mechanics were pulling these things apart and finding component failures that looked like the engine had been run without coolant. Nobody in Peoria wanted to hear it. The heat didn't just melt the wiring, it melted the trust the brand had spent 40 years building. When the warranty claims started outstripping the profits, the battle moved from the service bay to the courtroom. The money started disappearing even before the parts broke. Back in 2003, they had already paid $153 million in nonconformance penalties just to keep selling engines while ACERT was still being sorted out. That bill didn't get absorbed by the boardroom. When the 2007 EPA limits hit, Peoria had to bolt on a massive exhaust aftertreatment system just to stay legal. They didn't eat the cost of that new hardware themselves, they passed it to the customers as a massive emissions surcharge right on the invoice. When diesel hit $4.91 a gallon in 2008, the situation turned into a disaster. An ACERT C15 getting 5 miles per gallon when a good engine should get 6.5 wasn't just a headache, it was a death sentence for the bottom line of any small outfit running on thin margins. The computer systems made things even more frustrating for the guys in the shop. Their computers broadcast the basics over the standard J1939 data link, but for the deep stuff, they used a proprietary channel. You couldn't run advanced diagnostics or pull specific proprietary fault codes without buying the company's own electronic technician software and adapter, which meant independent shops were largely locked out. When a DPF clogged or the computer forced a shutdown on the side of the interstate, a driver couldn't just call a local mechanic. He had to pay for a flatbed tow to an authorized dealer just so someone with the right laptop could look at it. The legal trouble started hitting in waves. A massive class action lawsuit eventually landed in a New Jersey court representing 22 companies across 18 different states. Owners of 2007 model engines claimed that Caterpillar knew the exhaust systems were defective, but sold them anyway. In September of 2016, they settled the whole thing for $60 million while denying they did anything wrong. Here's what $60 million looked like in the real world. Dave Marson had spent $30,000 in direct repair costs before the engine bankrupted his company. His settlement check came in at less than $7,000, and then a stop payment was issued on it because of an administrative error. Leroy Bolton had spent 40 years building toward a retirement that a Cat engine took from him. He lost the truck, pushed retirement back by nearly a decade, and received less than $1,000. His wife Bess said that people were truly destroyed by what happened. Caterpillar had sold those men a reputation built over 40 years of bulletproof iron, and when the iron failed, the settlement math said they were worth $500,000 to $15,000 per engine. By the time those checks hit mailboxes, the company had been out of the truck business for 6 years. That settlement was the final invoice for a gamble they lost the day they decided the laws of thermodynamics were negotiable. On June 12, 2008, a man named George Taylor got on a call with the press and made it official. As the director of Caterpillar's global on-highway division, he announced that Caterpillar would not be building engines for the 2010 emission standards. After 50 years of owning the American road with legendary iron like the 3406B and the 6NZ, the biggest name in business was filing for a corporate divorce from the highway. Parker tried to blame the market, saying the truck manufacturers were building their own engines and there wasn't enough room for an independent supplier to make a profit. And that was the story for the public. The real answer was on the spreadsheet. In 2007, Caterpillar was pulling in $44.958 billion in global revenue. The North American truck division had just cratered by almost 60% in a single year, clearing roughly $1.2 billion, less than 3 cents on every dollar the company earned. A division that small, drowning in warranty claims and mounting legal liabilities, wasn't a struggling business unit, it was a liability. The suits ran the numbers on scrapping ACERT and building a compliant system from scratch, and the cost didn't pencil out. Mining, energy, and global infrastructure offered better margins with customers who had the capital to absorb complex engineering without a fight over the invoice. The exit from the highway wasn't a retreat driven by frustration. It was a cold calculation made in the glass towers of Peoria, signed off on a Tuesday, and executed without hesitation. The highway got the press release. The board got the capital back. That capital didn't sit idle. In 2011, Peoria spent $8.6 billion to acquire Bucyrus International and took control of the surface and underground mining equipment market in one move. Between that deal and parallel investments, roughly $12 billion rotated out of highway emissions compliance and into autonomous haul trucks, longwall miners, and hydraulic shovels working copper and iron ore deposits across 3 continents. If you look at the world's most powerful mining machines today, you'll see the Caterpillar logo. But if you peel back that yellow paint, you won't find Peoria engineering. You'll find a century-old secret from a Berlin workshop that the heavy equipment giant spent $8 billion to keep. Instead of giving up, the trucking world built its own way around the problem. Caterpillar was officially out of the game. But on the back roads of Tennessee and in workshops across the Midwest, a rebellion was already forming. Truckers had found a loophole, a way to run brand new iron with a forbidden heart, and for a few years it looked like they might actually win. While their lawyers were negotiating that settlement, something else was happening out on the asphalt. The 6NZ had become contraband. Not illegal, not yet, but the EPA knew exactly what those engines represented, and they were coming for them. Drivers and rebuilders were hoarding pre-emissions blocks the way people stockpile gold before a currency collapse, and they found a loophole big enough to drive a Peterbilt right through. There was a massive gap in the federal rules regarding glider kits. A glider kit is basically a brand new truck sold without an engine or transmission, and the law said the truck was regulated based on the year of the engine, not the chassis. If you took a pre-2002 engine and dropped it into a brand new 2018 Peterbilt 389, that truck didn't need DEF, SCR, or a DPF. As far as the government was concerned, that brand new truck was actually a vintage vehicle because the engine was the heart of the machine. For owner-operators who had been burned by ACERT failures and 5-figure repair bills, this was the perfect solution. You could have a modern cab with new safety features and a 6NZ block under the hood that didn't have any of the complicated exhaust filters. A 6NZ didn't require a permission slip from Peoria to stay on the road. Any diesel shop in the country could fix a single-turbo diesel for $75 an hour with a basic set of wrenches and no special adapter. Drivers reported that these trucks were down for repairs about 75% less than the new compliant models. A well-maintained 6NZ glider could easily go 700,000 miles before it needed a major overhaul, and that kind of reliability made the decision easy. A company called Fitzgerald Glider Kits in Tennessee became the headquarters for this entire movement. Tommy and Ricky Fitzgerald had been doing simple engine swaps since 1989, but when the 2010 laws hit, their business exploded. At their peak, they were building over 3,500 trucks a year and had a massive network of service shops across the country. Everyone wanted a Cat C15 6NZ in their build, not a Cummins or a Detroit. Fitzgerald had built a billion-dollar company almost entirely by picking up the legacy that Peoria had thrown away. The EPA eventually caught on to what was happening. Their testing showed that the older engines in these new gliders were putting out 43 times more NOx than the compliant truck on the highway. In 2016, the agency passed new rules that required gliders to meet the standards of the year they were built, which effectively killed the loophole. Fitzgerald tried to fight back with a study from Tennessee Tech, but the university eventually took the research back after finding major problems with how it was done. Between the new rules and a massive tax dispute with the IRS, the high-volume glider days were over. With the glider loophole closing, Caterpillar realized they couldn't just be an engine maker anymore. They tried to become a truck maker. But to do it, they had to make a deal with a partner that was already sinking. In 2011, they teamed up with Navistar to launch the CT660, a vocational truck wearing a borrowed coat of yellow and sold through their dealers. But the engine under the hood was just a rebadged Navistar MaxxForce, and Navistar was making the exact same mistakes they had made years earlier. They tried to use heavy EGR without DEF, aiming to certify at 0.5 grams per brake horsepower on NOx and use accumulated emissions credits to paper over the gap to the legal standard. The chemistry didn't care about the credits. The engine started failing just as fast as the A-certs did, and the mechanical collapse eventually landed Navistar in a $135 million class action settlement in 2019. The truck was a total flop, and by February of 2016, the boardroom officially ended the program and cut 70 jobs. The highway was officially closed. Here is what the suits in Peoria never wanted you to connect. The same month George Taylor was telling the trucking world that emissions compliance was too expensive and too complex to be reliable, their engineers were already laying the groundwork for the 3512E, a V12 diesel pushing 2,500 horsepower for oil and gas operations. That engine would go on to meet the EPA Tier 4 final standards, the exact same regulatory wall they told highway fleets was impossible to clear without gutting performance. It won the 2020 EPA Clean Air Excellence Award. The technology worked. It always worked. The question was never whether it was possible. The question was who was paying for it. The C-175 and the 794AC ultra-class mining trucks used a fully integrated SCR aftertreatment system. The exact setup Peoria had called a rolling chemical plant when highway fleets asked about it. Caterpillar marketed it to mining companies as the most robust and reliable way to hit emissions targets without losing performance. The system was the same. The customer was different. An independent owner-operator hauling a reefer from Kansas to Chicago fights for every tenth of a mile per gallon just to keep the lights on. A $15,000 DPF repair ends his business. A $500 sensor failure on the side of I-70 costs him a load, a broker relationship, and possibly his authority. He needs iron that any roadside shop can fix with a basic set of wrenches and a parts truck that shows up same day. Rio Tinto's 797F generates enough revenue per operating hour to pay for its entire emissions package in a matter of weeks. When a DEF sensor throws a fault code at that mine, a dedicated CAT field technician handles it before the next shift. The manufacturer didn't leave the highway because the technology was beyond reach. They left because the highway customer couldn't pay for what the technology actually cost to run right, and the mining customer could. Full stop. While Peoria was telling American truckers that the C-15 was a relic of a pre-compliance era they could never go back to, they were quietly shipping the exact same unregulated iron to the United States military. The national security exemption under 40 CFR 1068.225 allowed military equipment to ignore the Clean Air Act entirely. Stryker vehicles and MRAPs ran Cat C7 engines without a single DPF EGR cooler or DEF tank in sight, burning high-sulfur JP-8 aviation fuel that would have poisoned a civilian catalyst in hours. They kept those contracts alive through depot reset programs, building worn-out C7 blocks back to zero-mile specs and sending them back to the front lines. The same iron they told American truckers was legally impossible to build for a civilian customer. Down in Australia, the NC2 partnership was still assembling CAT's CT610 and CT630 trucks in Tullamarine until 2015, running C15A cert engines with passive filters and no SCR because local regulations hadn't caught up to the EPA. The company stockpiled nearly 400 trucks before the Australian deadline hit, squeezing every last sale out of the old rules. Technology was never the issue. The American profit margin was just too thin to bother defending. That calculation was already locked in when the Bucyrus deal closed in 2011. But here's what that acquisition actually bought, and this is the part most people miss entirely. CAT didn't invent their dominance in mining. They bought it from Germany. Specifically from a Berlin engineering firm called Orenstein and Koppel that had been building massive hydraulic shovels since 1893. Bucyrus had acquired the Terex mining division, which carried that entire O&K bloodline. When Peoria swallowed Bucyrus for $8.6 billion, they inherited the O&K RH400, a 980-ton hydraulic shovel that could move 45 cubic meters of rock in a single bite. They put the Peoria logo on it, renamed it the CAT 6090FS, and instantly owned the ultra-class market without spending a dime on ground-up research. They had already picked up Mack in 1997 for marine engines, and in 2011 grabbed Motorvenke Mannheim, a company tracing back to the inventor of the pre-combustion chamber. The electric drive systems in the 794AC and 798AC use traction motors and power inverters developed with Mitsubishi and Siemens, the same German firm building electric drives for mining shovels since 1981. They didn't invent the future of heavy power. They just bought the people who already had it, wrapped it in Caterpillar yellow, and deployed it in sectors where a single machine costs more than 100 highway tractors. Fast forward to today, and you'll see Cummins, Daimler, and Packer burning through billions of dollars to build a battery plant in Mississippi just to keep Class 8 trucks alive. That project is already behind schedule. The supply chain is a mess, and the massive costs are eating up what little profit margins they had left. Meanwhile, Caterpillar is busy digging up the lithium those batteries actually need to function. The 797F now runs autonomously 24 hours a day in lithium mines across South America, without a driver, a union, or any hours of service headaches. There is no DEF sensor to throw a fit at 3 a.m. on a mountain grade, and a single machine generates more profit than a fleet of highway tractors ever could. They didn't lose the highway, they just realized it was more profitable to own the ground underneath it. The 40 run from the 3406 to the final C15A cert didn't end because the iron failed. It ended because a division pulling less than 3 cents on the dollar wasn't worth the warranty exposure, the litigation, or the 9-figure R&D bill that 2010 compliance was going to demand. The spreadsheet architects did the math, cut the division, and redeployed the capital. In a boardroom, that's not a failure. That's exactly what boards are supposed to do. But a corporation is just a set of books, and down in the valley they abandoned, on some empty stretch of American highway, a rebuilt 6NZ is still pulling grades on a block that Peoria officially orphaned 15 years ago. The rebuilders are still turning wrenches. The old-school truckers are still paying $40,000 to resurrect iron that the suits wrote off as a liability. In 2026, a bare, non-running 6NZ core, no heads, no turbo, doesn't even start, trades for up to $8,500. That's not nostalgia. That's the market telling you the iron was never the problem. CAT quit the highway. The highway never quit CAT. If you've run a 6NZ or turned wrenches on one of these engines, sound off in the comments. Hit subscribe before you clock out. We'll see you on the next one.